Hey everybody, welcome to another video on Python for Linguists. Today we're talking about list comprehensions. As always with these videos, please be ready to use your fingers, use your brain to actually type along, code along. There will be quite a few exercises in this video. As always, the link to the slides is going to be provided in the description of the YouTube video as well as at the end of the slides here, so you can go through them on your own time, in your own time as well. All right, let's look at list comprehensions. So before we do that, I want to kind of set the stage. Creating lists from lists is something we very often want to do when working in Python. In the first homework exercises, we created new lists from existing ones, for example, to calculate type token ratio, where we first created a cleaned up word list to avoid noise like punctuation and sentence initial capitalization, for example. And for that, we started creating an new empty word list. We iterated over the old list with a for loop, and then just modified each element in our previous list and wrote it to the new list, right? The code would look something like this. I'm kind of making using a slightly different example here because some people still are working on the homework and I don't want to give any homework code away. So if we wanted to count the word lengths in a text and we have that text as a word list, we could do an empty list of word lengths for word in my word list. Length is then within the for loop defined as len word, and then for each of these calculated lengths, we append it to the word lengths list, right? It's entirely feasible. We can do this, but there is a faster and easier way to do this, at least if the operation is relatively straightforward. And that's a list comprehension, which we get in line 1 here, right? Word lengths is defined as len word for word in my word list. And that sort of gets enclosed in square brackets to indicate that we're expecting a list as the output. That's just to highlight this, exactly the same as the code that's reproduced here in lines 3 through 6, which is the code we just previously saw. And it may, when you first read a list comprehension like this, look a bit dense, but that's something you'll get used to really quickly because they are pretty pervasive. You'll learn how to read list comprehensions soon enough without any effort. And you can definitely see that it solves a couple of problems, right? It reduces the code to one line instead of four, and that line isn't particularly long or overburdened. It avoids kind of creating this empty list and does all of that under the hood. There is actually a slight optimization feature involved as well, and that list comprehensions tend to be just slightly more efficient than going over a list in a for loop, which may be relevant once we're talking about really big data analysis. So it's got a lot of beneficial consequences. Note when first getting used to comprehensions that there's a lot of similarity between both approaches here, right? They both call the original list, right? Here in my word list towards the end of the list comprehension, and in the for loop, we know the syntax, right? For word in my word list. And then they both define a loop variable that says basically do something for every item in the list. It's word here and word here, right? And in fact, this first statement that introduces the for loop, the syntax is exactly the same for this statement that basically here goes to the end of the list comprehension. And then we have some command that applies to every element that's captured by the loop variable. It's basically the first thing we write in the list comprehension, and it's the indented block of code that happens in the for loop. And then sort of the for loop gets entirely, the comprehension gets entirely rid of line 3 and line 6. These are built into the logic of a list comprehension itself. But if we focus on lines 4 and 5 compared to line 1, you can really see that it's really just writing writing exactly this minus the sort of storing something under an additional variable in a different structure, right? Len word for word in my word list. And once that sort of settles in, it'll make list comprehensions a lot easier to understand. For a human, the for loop is probably the most natural, intuitive way to think about iterating over data, but from there, it's really only a very small step to the list comprehension. Let's use our skills, our newly acquired skills, right away, um, and write a couple of list comprehensions. So let's assume you have something called my word list or my text or whatever, a large-ish amount of text in list format where every element in the list is a word. Write list comprehensions that achieve the following, that create the following new lists. One that's called initial list that has just every first letter of each word. One that's called lower list, that's just all basically the original text but in all lowercase. There's a slight hint for how to do this on the prompt here. And then probably the most challenging one, a list called nested list. And that's a list whose every element is another list. And that sort of interior list is going to be just a list of all the characters for every word, right? So you still have every word as an element in that nested list, but it's not a string element, but a list of individual characters. When or in case this gives you any trouble, go to the slides and you can scroll down here for the solution. All right, and obviously pause the video, take your time doing this. I'm just gonna sort of skip ahead and assume that that you'll press play once you're ready to continue. Something that's not code related directly, but that's more a sort of philosophical or applied question, is when you would choose between a for loop and a list comprehension. And Ramalho writes something that I think is very sensible. A for loop may be used to do lots of different things, scanning a sequence to count or pick items, computing aggregates, sums, averages, etc., or any number of other processing tasks. In contrast, a list comprehension is meant to do exactly one thing, that's to build a new list. And if you're not doing something with the produced list, then you should not use that syntax. If you're not interested in having, at the end of the day, having a new list that has certain properties, then the list comprehension is not for you. And I would say the inverse logic almost applies as well. If that's what you want to do, then you're usually pretty well served with a list comprehension. But slight caveat, also try to keep it short. If the list comprehension spans more than 2 lines, so if there's lots of added weight to it, we'll see a little bit of how to add weight to a list comprehension in a second, then sometimes it's best to break it apart and rewrite as a plain old for loop. Use your best judgment for Python as well as for English. There are no hard and fast rules for clear writing. And the notion he ends with here, clear writing, is really quite important, right? So the question is not necessarily one of which gets the job done faster. There's a slight argument to be made for list comprehensions, but the performance optimization isn't it's huge. And the much more important issue is that you write a piece of code and you'd like to be able to read it yourself when you pick that code up again 2 weeks down the line, maybe in 2 years, etc. And very often you also want other people to be able to read the code. And there is something to be said against completely cluttering a list comprehension. And if you want, within a for loop, if you want to apply 7 commands, seven separate commands, yeah, use a for loop, not a list comprehension. All right. Getting back to more applied stuff, let's do some more practice. Here's another exercise for you, and this really sets the stage for the next thing I want to do. So we're going to produce lists that just have true and false, or kind of just evaluate a list and return values of true and false. So we'll do this using a for loop initially, iterate over my word list, again, assuming that this is a text in word list format, and print for each item in a separate line, which is the default print behavior, whether the word that you're currently operating on is between 1 and 4 characters long, or in other words, shorter than 5 characters, or longer than that. And print true for the short words and false for the longer words. And once you've done this, do the same thing with a list comprehension. So create a new list of values true and false based on these conditions, right? The new list should simply be the Boolean values true, true, false, false, true, etc. Right? Again, pause the video. Again, access the slides. Scroll down for a solution. If it gives you a hard time, or if you want to check your solution against a model answer, and then please press play once you're ready to continue. So what this is useful for is to show that any sequence of items, we can apply a condition to, and that condition will be evaluated to true or false. And what we learned in the last video, that we can do with true and false, is that we can use this as a basis for conditional execution, right, with an if statement. So only if something applies, actually do something. And a list comprehension basically has that built into its logic. Towards the end, you can add if statements or an if statements, but you can combine conditions in that if statement. And that basically says the element represented by the loop variable, which is x here, only ends up in the new list if this condition is satisfied here. And if it's not satisfied, nothing happens. The new list simply sort of skips over this item, right? So if we wanted to extract only title cased words in my word list, you could write something like my title list, x for x in my word list. So just copy the old list. If you stopped here, you would have just created an identical list to my word list. But with this condition here, if x is title, you're basically saying get rid of most words, but only keep the title cased ones. Maybe we're interested in, named entities, proper nouns, etc. Probably want to do something about sentence initial capitalization here, but anyway, that's one potential use for this kind of code. And once again, to establish the correspondence to the for loop, we could also start with the empty my title list and then do for element in my word list. If element is title, my title list append element, right? This is the same thing. And again, if the if statement isn't satisfied, we don't have an else condition that, where we have code that would do something. So basically, if the condition isn't satisfied, nothing happens, in the sense that nothing gets written to my title list here. So those are basically identical in their outcome, but maybe you can see how this is a bit more elegant here to use a list comprehension. And with list comprehensions, you really just need to practice. So I tried to highlight primarily where they're similar to for loops, which we already know how to use, and then it's just a matter of getting used to this particular method. And in order to do so, I'll give you a final exercise. So find a longish piece of written English and assign it to a variable called my text as one long string. Then use splitting and list comprehensions to go from that one long big string object to a list of all ing forms in this text. And then try to calculate the following. What percentage of all types are ing types, and what percentage of all tokens are ing tokens, and how do these percentages relate to each other? Again, you can scroll down in the slides themselves for a solution if you want to access them. And I'll leave that with you as the last exercise. Just remember, life is short but beautiful. Believe in the beauty of your dreams. Here are my image credits. Here's the QR code and the link for the slides that this video is based on, which you can also find in the video description. Bye for now.